Alrighty guys, so this is the lesson video for topic 1.3, consumer choice. It's covered a little bit in chapter 2 and also chapter 6 of your books. I don't cover all the material in these two chapters. It's split. If you remember, previous topic, economics of a science, was also partially covered in chapter 2. So it's just little pieces that came together to make this topic. So recap from previous topics that are going to come through today is the idea of scarcity. So scarcity means society has unlimited wants and needs and a limited amount of resources to satisfy those needs. That leads to choice. Economics is the study of human beings under that scarcity condition, study of how we make choices. We talked about self-interest in market economies. We said it sounds icky, but it's really not. It's just the idea that individuals go around making exchanges, weighing the marginal benefit and the marginal cost of a decision. And marginal thinking, the last bullet point, breaking decisions down into smaller pieces to weigh the benefits and the cost, not all or nothing. So, the key questions for this topic are: how do economists measure consumer satisfaction? How do consumers make the best choices? And the last, what is something called the diamond water paradox? So, if we're going to talk about consumption, we have to talk about this concept called utility. So, utility is a measure of consumer happiness. So if you think about consumer choices, so consumption means purchasing something. You don't actually have to consume it and eat it and like food. But when you go to the store and you buy new clothes or you go buy some lunch at Chipotle, those are all consumption choices. So that's really what we're talking about in this concept. And economists are really fascinated with this idea. It has a lot to do with an economy, a lot to do with markets and supply and demand. So really, utility is kind of a study of how consumers make decisions. So measuring why people buy silly things or things that we might think are silly. Utility is an attempt to try and explain that. So utility is this concept that describes the satisfaction or usefulness you get when you consume a good or service. So as consumers, we can distinguish between want and need, right? Like I want a brand new iPhone versus I need a trip to the emergency room, and that'll determine how much we pay for each of those, and it's quite different. But utility kind of is this catch-all term for the value we put on things regardless of if it's a want or a need. So the unit that we use to measure utility is called utils. So it's kind of like happiness points is the way I like to think of it. So you could say that when I go to Chipotle and I get a burrito bowl, that's worth 10 utils to me. It measures the units of satisfaction or usefulness. You think of them like happiness points. So we say consumers go around trying to maximize their utility. So we're trying to spend our money in a way that we get the most satisfaction and the most usefulness out of it. So even though we might see silly purchasing decisions, so this is a screen grab from Kanye West's clothing line, and this is the hip hop t-shirt. It's a plain white t-shirt, and you can tell that it's listed on the website here for $120, and if you notice in little red, this red circle at the bottom, this item is completely sold out. Now, I think when you're wearing this white t-shirt, there's no way for anyone to distinguish whether or not it's something that came out of a Hanes t-shirt package at Walmart, but nonetheless, people have bought this item. It's the cheapest thing on the website, and have completely sold out of plain white t-shirts. So explaining how people maximize their utility and how it's different between individuals can help us explain very silly or what appears to be silly consumer choices like this one. So, a few notes about utility is that we cannot compare it between individuals. So for example, if I have two people, John and Steve, and we're talking about their utility from consuming a sandwich, and John says, I like this sandwich, I'm going to say that this sandwich is worth 20 utils for me. And Steve says it's worth 10 utils to him. I cannot say that John likes the sandwich twice as much as Steve does, right? Even though we are technically using the same unit, utils, each person is going to have a different scale. So happiness is unique to the individual, and our measure of happiness is going to be different. So everyone can have their own scale. So maybe John is using Celsius to measure, and Steve's using Fahrenheit, right? Because that scale is unique to the individual, I can't definitively say that John likes this sandwich more than Steve, because who knows how John versus Steve judges happiness within their own self. So we say we cannot compare utility between individuals. However, we can compare utility between items for a single individual. So for example, if I just take one person, John, and I ask him what he wants for lunch, how does he measure the utility of a sandwich versus a burger? He gives the sandwich 20 utils, the burger 30 utils. I can say for certain that the burger is going to provide more satisfaction to John than the sandwich would. So you can compare internally because there's just one scale for one person. You can't compare between individuals. All right. So we also distinguish in economics between total utility and marginal utility. So total utility is the overall amount of happiness you get from consumption. So we generally say that people go around trying to maximize their total utility. They're trying to spend their money in a way that they get the most amount of utils or happiness points from what they choose to buy. Marginal utility, if you remember from topic 1.1, I said every time you hear the word marginal, I want you to think additional. So marginal utility is the additional utility you get from consuming one more unit. So it's that extra benefit of just a little bit more. Generally speaking, we say we want to maximize total utility, and we want to keep on adding when there is positive marginal utility. So if I'm going to get a positive amount of utils or additional utils, that's going to add to my total happiness. So we want this guy increasing and adding in value, and we want this value maxed out altogether. We can also express marginal utility as a function or an equation. So we know marginal utility means additional. So MU for short, that's for marginal or additional utility. Marginal utility. We say that is equal to, and it's a fraction, the change in TU. TU here means total utility over the change in the quantity. And this is the amount that you consume. So I know this little triangle might be throwing some of you off. It might look scary, but it's just a short way to say change. It's the Greek letter delta, and in math we use delta to represent change. So this is just a shorthand way of saying change in the total utility or change in my total happiness over the change in consumption, or how much extra. How much more happiness did I get over how much more I had to consume? That's marginal utility. All right, so marginal utility actually matters more than total utility when we're making our consumption decisions. So if you remember from topic 1.1, the fourth foundation was make decisions at the margin, meaning don't make things based on an all or nothing choice, weigh a little bit more versus a little bit less. So in economics, we have this law called the law of diminishing marginal utility. So that says as we consume more of a good or service, the utility we get from the additional units tends to become smaller than what we received from earlier units. So there's a really easy way to explain the law of diminishing marginal utility, and it is thinking about going out to eat pizza with your friends. Okay, so if you go out with your friends to get pizza and a big pizza comes to the table, a lot of the time you don't make an all or nothing decision right then and there. You don't put precisely 3.5 slices of pizza on your plate and decide right then that's how much you're going to eat. You probably take it at the margin, one slice at a time, weighing a little bit more versus a little bit less. So the pizza comes to the table and you think about the costs versus the benefits of slice number 1 Cost would obviously be, the amount you're chipping in for the pizza, for that one slice of pizza. The benefits are quite high. Pizza's delicious. You eat slice of pizza number 1 after you figure out the benefits outweigh the cost. Then you think about slice of pizza number 2. And now slice of pizza number 2 is also delicious, but it's not quite as delicious as that first slice. That first slice, when you're super hungry, it's just so good. It's delicious, right? Most of the time, that first one is going to be better, so the second one's good. It just wasn't as delicious as that very first slice when you were starving. But you do go ahead and eat slice of pizza number 2. Then you think about slice of pizza number 3. The pizza's still good, but you've already had 2, and the calories from the pizza are starting to add up. Let's say you do weigh the benefits versus the cost. You decide to eat slice of pizza number 3, but it wasn't quite as good as the second slice, and it certainly wasn't as good as the first slice. Then you start to think about slice of pizza number 4, and if you're anything like me, if I eat more than 3 slices of pizza, I'm going to get a stomach ache. The benefits certainly don't outweigh the cost. I decide to stop at slice of pizza number 4. So that idea that the first slice of pizza was the most delicious, the fourth slice of pizza wasn't even worth it, and as I consume more and more pizza, the second slice wasn't as good as the first, the third slice was even less as good. That is the law of diminishing marginal utility. As you consume more of a good, the utility you get from the additional ones is less than the earlier ones. So we can also calculate marginal utility using our little equation from earlier. So if I were to give you a table with some information here, I have the number of Oreos eaten. We could also call this the quantity of Oreos consumed. And over here I have my total utility, or TU. So based on this, I can find the marginal utility, okay? So remember, marginal utility is the change in total utility over the change in the quantity. So as I move from no Oreos to the very first Oreo, my total utility goes from 0 to 25. So if I were to plug that into this fraction over here, where is my pen? There it is. My total utility, the change in total utility, went from 0 to 25, or I've got an increase in 25 up top, and the change in the quantity, or the number of units I consumed, went from 0 to 1, where that's an increase of 1. 25 over 1 is 25. So my marginal utility from the first Oreo is an additional 25 units of happiness. Okay, then things get a little bit more challenging. The second Oreo brings my total up to 45. Now, if I want to find the marginal utility of that second Oreo, I need to use that same equation. So for the second Oreo, my happiness points went from 25 to 45 in total utility. So that's an increase, or a change of 20, right? Because it took me 20 more to get to 45 from 25. So this number up top is now going to be an additional 20 utils. And then down here we need the change in quantity. We go from 1 Oreo to 2 Oreos, so that's an increase of 1 again. So 20 over 1, still 20. So my additional utility here is 20. And you might have noticed here, I'm increasing my quantity going from 0 to 1, and 1 to 2, and 2 to 3, and 3 to 4. So I'm going to be dividing by a plus 1 every time. So really, to find the marginal utility here, you can just find the difference from one row to the next. So for the third Oreo, my total utility went up to 60 from 45. So that's a marginal utility of 15. For the fourth Oreo, we go from total utility of 60 to 70. That's going to be 10. And then from the fourth Oreo to the fifth Oreo, it goes up to 75. We got a 10, we got a 5. For the sixth Oreo, my utility stayed the same. I didn't get any extra benefit or the cost and the benefits may be canceled out there. And then Oreo number 7 actually lowers my total, and Oreo number 8 lowers it even more, right? Because my total utility dropped here. So in our case, I certainly would not want to eat Oreo number 7 or 8. It doesn't help me maximize my utility. In reality, I would want to eat 5 or 6 Oreos because that's where I maximize my utility. Safest bet is going to be go where I have no more additional marginal utility. I'm not missing out on any more. All right. So here I have graphs of total and marginal utility, and I want you to be able to figure out whether I give you the information in a table like this or a graph like this. If I give you the total utility, I want you to be able to calculate the marginal, just like we did here using our equation. But if I were to give you a graph of marginal utility here, I would want you to be able to figure out the total as a result. So for example, let's ignore this graph on the left. Let's just look at this graph on the right of marginal utility. And let's try to calculate the total at 3 Oreos. So at 3 Oreos, my marginal utility is going to be 15. So how do I get the total from that? Well, all you have to do is add up the marginal utility from the first 3. So you know if we're eating 3 Oreos here, that last Oreo gave you 15 units of marginal utility. If we go backwards, the second Oreo provided 20 units of marginal utility, and that first Oreo provided 25 units of marginal utility. So at this point, 3 on the graph, I just have to add up each value to get my total. So I have to take 25 plus 20. That's 45, plus 15, that's going to be 60. So based on the information here in this marginal utility graph, I can find the same result here. Total utility, this is a total utility graph. Number of Oreos is going to be 60 at 3. 3 Oreos provides a total utility of 60. Okay. So I do want you to notice the difference in the shape of these graphs. So this information is related, but it's not the same. Total utility is not the same as marginal utility, even over the consumption of the same products. So this shaped graph, where we have total utility, we call this a convex graph. So if you remember that from topic 1.2, where it kind of loops over like this, we've got a positive slope here, and then it goes negative. So this is my increasing total utility all the way up to the 6th Oreo. Then my slope goes negative because I don't want to eat Oreo number 7 or 8 because it's going to give me a stomach ache here. This is going to be a purely negative slope here because that shows the law of diminishing marginal utility. The first Oreo was better than the second, which is better than the third, better than the fourth, etc. And then by the time we get to Oreo number 7 and 8, my additional utility is actually negative. It lowers it. So 2 different graphs related to one another, not perfectly the same information. All right, so now we're going to talk about some ways to avoid some consumption choices. So hit pause here, watch this video. This is an advertisement for endless shrimp, which is a special they do at Red Lobster, and I think they do something like that at Outback as well. So hit pause here, go to supplemental video tutorials for topic 1.3, consumer choice, and then come back here. Alright, so if you watched that video, you saw the ad for endless shrimp or bottomless shrimp. Lots of restaurants do this. And at Red Lobster, endless shrimp starts at $15.95 or $15.99. And a lot of people, when they do these all-you-can-eat type of things, whether it's a buffet in general or one of these specials at Red Lobster, a lot of times the mentality is to always get your money's worth, right? So if you were to try and get your money's worth at Red Lobster and essentially eat more than $15.99 worth of shrimp, you'd have to eat about 100 shrimp, and that would probably give you a bellyache. So there's this common mistake that people make when they're trying to eat their money's worth and they go to a buffet and they eat too much, they overeat because they're trying to get their money's worth, is they fall for something called the sunk cost fallacy. So in economics, there are some costs that we call sunk, which means you can't get them back, and so they shouldn't be involved in our marginal decision making. When we make marginal decision choices, we always kind of want to look forward. We don't want to look back, right? So when you purchase endless shrimp at Red Lobster and you sit down at the restaurant, the waiter comes up to you and they say, "Hello, what would you like to order tonight?" And you say, "I'm going to do the endless shrimp." That $15.99 is gone. We say it's sunk, right? So the only thing you should be considering as the waiter keeps bringing out plates of shrimp, you shouldn't be thinking about that $15.99. All you should think about is, do I want to eat this plate of shrimp that the waiter's bringing out, or do I not? The benefit is going to be eating more shrimp versus the cost. So when plate number 1 of shrimp comes out, probably the benefits outweigh the costs. When the second, third, and fourth start to come out, that's when you start wondering if the marginal benefit is worth the marginal cost. Plate of shrimp number 5 is coming out. The waiter's carrying it out to you. You do not need to be thinking about the $15.99 you spent. You don't need to say to yourself, "You know what, I spent $15.99. I have to eat this 5th plate of shrimp because I need to get my money's worth." That $15.99 is gone. When plate number 5 comes out and you're looking at it and feeling sick, don't eat it, right? We don't want to consider sunk costs. We only want to make decisions at the margin, which is, how much benefit is that 5th plate of shrimp going to give you? Probably not that much. You've already had 4 plates of shrimp, versus the cost, a stomach ache, and make that choice there. Probably it's not worth it. The sunk cost fallacy is really, really tempting for a lot of people, because it's easy to fall for it, because if you are to not fall for it, it means a lot of times you have to admit that you made a mistake earlier, right? When plate of shrimp number 5 comes out, even though it's very clearly not worth it to you at the margin, some people might want to eat it anyways because they don't want to admit that they shouldn't have ordered endless shrimp in the first place, right? They made that mistake at the beginning. So that's why it's a really common mistake. Some other examples of the sunk cost fallacy might be sitting through a really, really bad movie that you bought a ticket to. So if you've ever bought a ticket to a movie, gotten in the theater, and 10 minutes into the movie, you're like, "Wow, this is terrible," and you hate it. And you're sitting there, and you're not enjoying yourself, but you keep sitting through the movie because you paid $10 for a ticket. That's an example of the sunk cost fallacy as well, right? Once you pay the $10 for the ticket, that money is sunk. It's gone. So if you're sitting in a movie and it turns out to be terrible, well, don't continue to pay for it with your time. Just get up and leave and go do something else that you enjoy more, right? Make a choice at the margin. Another mistake is staying in a bad relationship for way too long. If you've ever dated someone and the relationship's just not good anymore, you guys aren't enjoying each other's company, some people might think to themselves, "Well, I've already invested so much time and effort developing this relationship with my boyfriend or my girlfriend or my partner, whoever it is." Don't think about that. That time is sunk. You're not getting it back anyways. So if the relationship's not making you happy, leave them, right? Break up with them. So didn't think you were getting life advice in economic class, but here you are. Sunk cost fallacy. Don't fall for it. All right. So back to talking about utility and marginal utility. So we know we have this law of diminishing marginal utility, the idea that as you consume more and more of something, the second and the third unit give you less and less utils or less and less additional benefit. So there is this idea of, could marginal utility ever increase? The answer is yes. Sometimes our consumption, or the benefit from our consumption, actually increases with the second unit compared to the first unit, but it is always rare and it's always temporary. So there's a couple of examples here. The first one might be running. So if I have any athletes or runners out there listening, and you enjoy running, a lot of times those first few minutes of exercise kind of aren't great because you're still tight and loosening up and you're warming up. So sometimes maybe 10 minutes into your run, you're actually enjoying that better than the first few minutes. So that would be actually increasing marginal utility, right? You get more benefit from, the between 10 and 15 minutes of running than the first 10 minutes of running because you're still warming up during that time period. But then eventually, as you continue to run, you get more tired, and eventually that marginal utility will decrease as well. Another good example would be alcohol consumption. So if you're of age and you've been out drinking, the first drink, the first cocktail, doesn't taste that great, doesn't do a whole lot for you. But after you've had a couple beers, maybe then the third beer helps get you a little buzz. So sometimes beer number 3 gives you more marginal utility than the first 2 did. But just like with running, drinking, as you continue to drink more and more, that additional benefit will plummet very quickly and you'll get sick if you're not careful. So the idea of the law of diminishing marginal utility is that eventually, as you continue to run or to consume alcohol or to do anything, is that it eventually declines. At some point, those additional successive units of consumption are going to provide less benefit. So yes, marginal utility can increase, but it's rare and it's always at the beginning, just kind of temporarily. Okay, so now we're going to combine this idea of utility with how we make purchasing decisions. So we have this model here that is going to help us combine the idea of utility with consumption. So it's going to be a simplified version of reality. We know people go around trying to maximize their utility, and they make purchasing decisions and make budgets and things like that, trying to spend their money on the things that are going to maximize their utility. And in reality, when we make budgets and when we spend our money or our paycheck, we have thousands of goods and services we can choose from. But as with most models, we're going to simplify it. And so we're going to imagine a world where you only have 2 things that you could possibly buy. Coffee, which costs $2, and bagels that cost $4. And let's say, hypothetically, you have $20. That's your budget. And so you're going to decide, how do I spend my $20 in this very, very simple economy to maximize my utility? We've got a few options, and we can show those options on something called a budget constraint. So a budget constraint shows all possible consumption combinations that you can afford given the prices and all income being spent. So a budget constraint is going to be a downward sloping line, and on the graph you're going to put one good on the y-axis. For us it's cups of coffee. You're going to put the other good on the x-axis. Here it's bagels. And this line is going to be downward sloping because of the idea of opportunity cost. There's going to be an inverse relationship between cups of coffee and bagels, because if I buy more bagels, it means I can afford less coffee, and vice versa. If I buy more coffee, it means I can afford less bagels. So every point on this graph, A, B, C, D, E, and F, are all points we can afford when spending my $20. So point A shows me spending all my money on cups of coffee and no bagels. So on the previous slide here, I said coffee was $2 and bagels were $4. So on this graph, if I spend all $20 on cups of coffee, I can have 10 cups of coffee. That'll be all $20. Vice versa, point F is if I spent all my money on bagels, and if I bought just bagels for $4 each, I can afford up to 5 of them. And then B, C, D, and E shows other combinations if I were to split my income. So the question here is, this is what I can afford. Which one of these points am I going to choose based on the idea of utility? I could buy all coffee and no bagels, all bagels, no coffee, or I could buy one of these combinations. But would I prefer B to C or C to D? Probably I'm going to prefer a little bit of variety, but we have to combine this idea of what we can afford with what we want. So this is the way that we make purchasing decisions. So you choose a good that gives you the most marginal utility per dollar. So we take the marginal utility of each cup of coffee over the price of a cup of coffee and compare it to the marginal utility that a bagel would give me versus the price. So if you've ever heard the phrase bang for your buck, that just tells you how much, it's kind of like this little catchphrase for how much benefit you get for the price of something, something being a good deal. This is literally kind of an economics equation for bang for your buck, right? The benefit of something over the price of something. And we can simplify this term as the utility per dollar spent. So I have this table here, and we are going to calculate our little value, the marginal utility per dollar, in this column. So I'm going to move over here in a little bit. I actually have them calculated out here. So the way we're going to do it is just using this equation, the marginal utility, which I have in the table, divided by the price. So just to recap, coffee is $2, that's our price of coffee, and bagels are $4. So to fill in this column here, for coffee, I'm just going to take the number in this column and divide it by the price of coffee, which is $2. So 18 divided by 2, that's going to be 9. And over here in the bagel column, the price of bagels is 4. So I'm going to take the marginal utility and divide it by 4. So all the numbers in this column divided by 2, because that's the price of a cup of coffee, and all the numbers in this column divided by 4, because that's the price of a bagel. So for the second one, 16 over 2, that's 8. Over here, 32 over 4, also 8. And if you were to finish out that column, you'd get something that looks like this. All right, so now I've calculated the bang for your buck type value. This is the same table. Now we kind of need a method to figure out how much bagels and coffees are we going to use. So we are looking for something called the consumer optimum. So I've got some steps for you for finding a consumer optimum. Consumer optimum. So you can kind of just summarize these steps. I think they're in your concept guide. So the first step for finding the consumer optimum is calculating marginal utility per dollar for the whole table. Okay, and then steps 2 and 3 is using something called the cross it off and subtract method. So what you're going to do is you're going to compare the marginal utility per dollar for each item and pick the bigger one. You're going to pick the item that gives you the most bang for your buck, and we cross it off. So cross off the bigger marginal utility per dollar. And that's going to represent that we bought it. And then the third item is to subtract the price from your overall budget. So now that we've calculated marginal utility per dollar, we're going to work our way down the list, comparing them and crossing off the item with the most bang for our buck and subtracting that price from our budget. And then we stop when we run out of money. And when the marginal per dollar is equal. So I know that's a lot of information I threw at you all at once, but it'll make sense with my example here. So we've already done step 1. We calculated the marginal utility per dollar here, right? That's the marginal utility per dollar for cups of coffee. Here's the marginal utility per dollar. So step 2 means we make our purchasing decisions by comparing these two. So marginal utility per dollar, bang for our buck, and our budget is $20. So I like to write $20 here at the side of my table. So let's say you walk into this little breakfast place and you consider buying cup of coffee number 1 versus bagel number 1. Cup of coffee number 1 is going to give you 10 marginal utility, or 9 units of marginal utility per dollar, 9 bang for your buck, versus the first bagel is going to give you 10. And you want to pick the larger one of these. Bagel number 1 gives me more bang for my buck, so I'm going to buy this first bagel. So I'm going to cross it off my list. I already bought bagel number 1. So that's step 2. Cross it off. Comparing the two, I crossed out the larger one. Step 3 is to subtract. So I bought bagel number 1. The price of a bagel we established earlier is $4. So now I have $16 left to spend in my budget. So we're going to do this again. So now I've already bought my first bagel. That's why it's crossed off. Now I decide, how do I spend my remaining $16? I can buy a second bagel and get 8 units of marginal utility per dollar. Or I can buy my first cup of coffee. I haven't bought any yet, right? So I'm comparing bagel number 2 versus cup of coffee number 1. This one gives me more bang for my buck. 9 is greater than 8. So I'm going to go ahead and buy that first cup of coffee. Cross it off here. So now I have 1 bagel, 1 cup of coffee. Don't forget to subtract out that cost of that cup of coffee, which is $2. Now I've got $14 left to spend. Okay. Now I compare, do I buy a second cup of coffee or do I buy a second bagel? Here, they've got the same value of marginal utility per dollar. So which one should I pick? Well, if I like them both equally and I can afford both, I want to go ahead and buy both. So I buy that cup of coffee and I buy that bagel. So in this case, I spent $4 on a second bagel and $2 on another cup of coffee, so that's minus $6. Now I have $8 left. Okay. Now I have to debate a third cup of coffee versus a third bagel. And this one gives me more bang for my buck, so I go with the coffee. So that's another $2 spent, minus $2. That's a dollar sign. Draw 2 lines through my dollar sign here. Kind of looks like a 12 for a second. $6 left. All right, so I've got 3 cups of coffee, 2 bagels. I debate a third bagel versus a fourth cup of coffee. My bang for my buck, my marginal utility per dollar is the same for these guys. I can afford both, so I buy both. Buy bagel number 3, cup of coffee number 4. That's a total of $6 spent. And I'm out of money, so I'm done. So if I go back to my steps over here, we kind of repeated steps 2 and 3 over and over again. When all of my money is spent, we did that, went to $0, and the marginal utility per dollar is equal for both goods. So for that last unit that I purchased here, the third bagel, marginal utility per dollar was 6. Over here, marginal utility per dollar was 6, so I satisfied my last rule. So that's kind of your code for figuring out the consumer optimum. So back at the beginning here, when I looked at a budget constraint, turns out I would like to purchase 4 cups of coffee and 3 bagels. Point D here was the affordable option that gave me the most bang for my buck. So I picked this point on my budget constraint. Kind of cool. Much easier than having to calculate total utility based off of the marginal utility I started you off with. The cross it off and subtract method is much easier than having to go through and add up for each point on the budget constraint. You could do it that way. So this is point A on the graph. This is point, A, B, C, D, E, F on the graph. If I gave you this initial table that we started off with, you could just add up, how much additional utility would I get from 10 cups of coffee? Just add all these up. That's point A. Add all these up, or add all these up to point 5. That's the last point on the graph, and compare them. But that is very time consuming. The cross it off and subtract method I think is easier, though you can see that we do maximize total utility at that same point on the graph. 3 bagels, 4 cups of coffee. So I actually have another example that we can do. But I do want you to know at the end of finding the consumer optimum, I have to have those two conditions that I talked about in my steps, in step 3, listed. You have to spend all your income, and for the last unit purchased, the marginal utility per dollar has to be equal. If one of these is greater than the other, it means that you could have spent your money more efficiently. One of them is giving you more bang for your buck. So you need both of those satisfied. So most people complain that budget constraints aren't very realistic, that in reality you're not choosing to spend all your money between two things, but you can kind of expand the idea of a budget constraint to compare to more than 2 items. So the next example we're going to do is actually with 3 items. So here's another situation where you can find the consumer optimum. So Andrea has a $27 monthly fast food budget, and she can buy 3 things: sub sandwiches, which cost $5 each, burgers, which cost $4 each, and tacos that are $2 each. So here I have basically 3 sets of information. I have the number of subs, the marginal utility, and we're going to calculate the marginal utility per dollar for each item here. So I'm going to move back to my little sketch pad, and we're going to follow my same 3 steps here. So step 1 here is calculate the marginal utility per dollar for the whole table. So before we get started, I am going to go ahead and write down the price of each item. So over here, sub sandwiches are $5, burgers are $4, and tacos are $2. So I'm just going to write that here. So price of a sub is going to be 5. Price of a burger is 4. And price of a taco is $2. And I'm going to write my budget over here. So it says the budget here is going to be $27. So I can do my cross off and subtract later. $27. All right, so step 1. Calculating the marginal utility per dollar for the sub sandwiches. Take everything in this column, divide it by the price, which is $5. So for the first one, here, 50 over 5, that's 10. 45 over 5, that's 9. 40 over 5, that's 8. And this guy is 7. I'm just using a calculator here. You can use a calculator on your test. You can use it here. Okay, price of burgers is $4. So we're going to divide each of these by the number 4. 36 divided by 4 is going to be 9. 32 over 4 is 8. 28 over 4 is 7, and 24 over 4 is 6. For tacos, everything costs $2, so 20 over 2 is 10, 16 over 2, 8, 12 over 2, 6, 8 over 2, 4. So that's step 1, done. Step 2 and 3 here, we're going to do our cross it off and subtract. So we're going to compare those marginal utilities per dollar for 3 items and pick the bigger one, subtract off the price of that until I run out of money and they're equal to each other. So our fast food budget is $27, so we're going to compare sub number 1 to burger number 1 to taco number 1. Looks like sub and taco number 1 both give us the most bang for our buck of 10. So I'm going to cross them off. So I spend $5 on a sub and $2 on a taco. That is going to be $7. I got those prices from up here. My taco cost $2. My sub cost $5. Now I have to debate burger number 1 versus sub number 2 versus taco number 2. Burger number 1 and sub number 2 both give me 9 marginal utility per dollar, so I buy both. Cross this off. Cross this off. So I just spent $4 and $5. So this was $20. And I just spent another $9. Now to $11. Okay. My third sub, my second burger, and my second taco all give me a marginal utility per dollar of 8. So I buy each of these, cross it off. And so that is going to be me spending my money on one of each of these, 5 plus 4 plus 2. So that is going to be minus 11. So I've run out of money, satisfied that condition. For the last units purchased, they have the same marginal utility per dollar. And so I satisfied my 2 conditions. So the consumer bundle in this case, the answer to this question, if it were to be on the test, would be 3 subs, 2 burgers, and 2 tacos. Okay. Now, I occasionally will get students who will look at this last question and think, well, could I maybe buy 2 more tacos and forget the burger and buy these last 3 tacos and get even more bang for my buck than over here? Well, remember that our goal is to maximize my total utility by spending the budget. So marginal utility per dollar isn't what we're trying to maximize. What we're trying to maximize is our total utility by using these rules, comparing these one at a time. So this is the consumer optimum. This is the bundle that's going to make us better off. So even though you might look at this list and think, well, I could have 4 tacos if I just got rid of that burger or whatever, that's fine, but I'm giving you the marginal utility for my hypothetical consumer here. This isn't you making the decision. I've given you the hypothetical marginal utility. And this person likes subs and burgers a lot more than tacos, even though you might personally like tacos better. So try to follow my method here, and that's the way you'll get to the right answer. So here I've just circled the answer. All right. So the last key question of the chapter is, what is the diamond water paradox? So the diamond water paradox is something that our good old friend Adam Smith wrote about. So he has this quote: "Nothing is more useful than water, but it will purchase scarcely anything. Scarcely anything can be had in exchange for it. A diamond, on the contrary, has scarcely any use value, but is very great quantity of other goods may frequently be had in exchange for it." So that's just him observing the idea that water is super cheap. However, we need it for all sorts of stuff. Diamonds, on the other hand, we don't need it for practically anything. They're just these shiny rocks, but they're very expensive. And that was confusing. Why is it that something that we really need, we're not willing to pay as much for, water, but something like a diamond that we don't need is worth quite a bit of money? And the answer lies in the idea that we make consumption decisions by using the idea of marginal utility versus total utility. So the reality of the diamond water paradox is this, or the explanation of the diamond water paradox is this. And you can put this in your notes. It should be in the concept guide somewhere, is that marginal utility matters more for consumption decisions than total utility. When we make decisions, we make them at the margin. We don't make all or nothing decisions. We don't make total utility decisions. We make them at the margin. So Adam Smith's confusion here is he's comparing the total utility of the 2 items. If it was an all or nothing decision between water versus diamonds, the total utility of water absolutely outweighs the total utility of diamonds. I need water to survive, to drink in the desert, but water is quite abundant, so I can use it for those very, very high value options like drinking and cooking. And then I have so much more, I can use it for some of the lower value uses like filling up a fish tank or washing my car or watering my lawn like I have listed here. So essentially, the marginal utility of water is quite low because I've already consumed quite a bit of it. Whereas diamonds, I don't have quite a bit of extra diamonds lying around, so the marginal utility of that item is quite high. So The answer to the diamond water paradox is that a lot of times our value of an item is determined by the marginal utility versus the total utility. So even though water is in total more useful than diamonds, diamonds are more valuable because their marginal utility is higher. So that's about it. This is just kind of a recap of our key questions. If you have further questions, shoot me an email. Definitely check out some of the supplemental materials and try out those assessments. Finding the consumer optimum is probably the trickiest part of this topic, but with some practice, you'll get the hang of it.